Alright, so today we're looking at basic differentiation rules and rates of change. So you're going to like this way better than 2-1. Like I said, there's rules that apply in place of the delta x and those types of things. Alright, so 2-1 we use what's called the limit definition to find the derivatives. And this and the next two lessons will be introduced to several of the differentiation rules that allow us to find derivatives with direct use of the limit definition. Alright, so these ones are going to save us a lot of time. So first off, we have the constant rule, which is theorem 2.2. Constant rule says the derivative of a constant function is 0. That is, if c is a real number, then d dx of c is 0. So let's look at a couple examples using the constants rule. So constants rule, we have, I use a function, and what I'm going to do for each one of these, I'm going to give it to you in several different notations, just so you kind of see them all, see what they look like, and you're not confused when you see them in the future. So if I have y equals 7, that's my function, y equals 7. So I'm going to say dy dx, which means the derivative of function y with respect to x. Is 7 a constant? Yeah. So what's the derivative of it? 0. Okay. If I have f of x equals 0, is 0 a constant? Kind of, right? What's the derivative of 0? Trick question. It's 0. Alright, so f prime of x would be 0. And say I have s at t. S at t means nothing different. It just means f of x, just different letters. So say it's -3. So s prime at t, or the derivative of function s, would be what? 0. There it is. That's the first rule. Alright. So next one. This is probably one of the bigger ones. Remember that problem you had on the quiz? I believe it was f of x equals x cubed plus 3x. Does that sound right? And remember, it took what, half a page of notebook paper to do it? All right. And I told you guys the answer was going to be 3x squared plus 3. Remember that? Okay. All that did was combine the power rule and the constant rule, essentially. All right, so let's look at this one. So it says, if n is a rational number, then the function f of x equals x to the n is differentiable, and ddx of x to the n equals nx n minus 1. And for f to be differentiable at x equals 0, blah, blah, blah. All right, what does this mean? Okay, ready? If I have function of, let's go with f of x equals x to the third. Okay, so the derivative, what you want to do is you want to take the exponent. What's the exponent on this one? 3. Take the exponent, put it out front. All right, so I bring that 3 down, put it in front of the x, and I subtract 1 from that power. So 3 minus 1 is 2. So f prime of x is 3x squared. Now, I didn't really go through the proofs of this and stuff. You guys all right if we don't spend time on the proofs? Okay, I figured you'd be all right with that. All right, so all you had to do is take the exponent, put it out front, subtract 1 away from the exponent. That's really all it is. Okay? Now, that's a really basic one. So the other place you see this is roots and like fractional stuff too. All right, so let's look at another one here. we'll go g of x equals the third root of x. Now, if we remember, a third root of x is the same as x to what power? 1/3. Yeah. Okay. So this is the same as x to the 1/3. So a lot of times it helps to rewrite that first. So now I'm going to have g prime of x equals, well, now I'm going to have 1/3 out front, right? 1/3 x. Now what's 1/3 minus 1? -2/3. There you go. Now what's the problem here? Can't have negative exponents. You got to take it to the bottom, right? So we can just take the x to the bottom with that 3. So that's going to be 1/3 x to the 2/3. Same rule. Take the exponent, put it out front, subtract 1 from the exponent. Right. If I have, so I'll use this one a little different. Y equals 1/x². Okay. So this one here, it's a different setup, so I just can't write y prime because I don't have the x in there. So we'll go dy dx. So the derivative of function y with respect to x. Now this one here, it doesn't really fit the power rule, does it? All right, because it's on the bottom, and you really just can't do it on the bottom and get away with it. So what you want to do, you want to bring it to the top. So when I bring this to the top, now I have x to the -2, right? So I did anytime I take something from the bottom to the top or the top to the bottom, I change the sign of the exponent. All right, so I'm going to rewrite that as x to the -2. So if that's x to the -2, I can bring the -2 out front. X. And then subtract 1 from my exponent. So -2 minus 1 is -3. Now again, I'm dealing with the negative exponent, right? So I got to take it back to the bottom. So that's going to be -2/x to the third. And believe me, if you didn't have that rule, that one would be way, way, way uglier. All right, questions? All right with that so far? You're not too mad at me yet, are you? Sure? All right, let's find the slope of the graph. So we want to find the slope of the graph of f of x equals x to the 4th. Now, if you want to find the slope of a graph anywhere, all you got to do, find the derivative, plug the value in. Okay? And we want to find the slope of the graph at x equals -1, 0, and 1. All right? First thing we got to do, we got to find f prime of x. So f of x is x to the 4th. What would f prime of x be? Using the power rule. Yep, there you go. Power out front, subtract 1 from the power. Okay? So that is my f prime of x. So then all I'd have to do is plug in those numbers. Okay? So let's find -1. So f prime of -1 is going to be 4 times -1 to the third. So the function x to the 4th is going to have a slope of -1 to the third. That's going to be 3, so it's a negative. Being the slope of -4. That would be the slope of the tangent line at that point. Okay? Next one, f prime of 0. Plug a 0 in for x. That's just 0 and 0. The slope would be 0. then f prime of 1, 4 times 1 to the third is going to be 4. All right, so again, the derivative is the slope of the tangent line. Okay, it provides a tangent line. If you then you find the slope of that tangent line, you just plug in that value. All right, so let's expand a little bit more. So look at the next one. We want to find the equation of the tangent line. All right, so we want to find the equation of the tangent line to the function f of x equals x squared, and we want to find it when x equals -2. So in the last problem, what we did was we just found the derivative, plugged the number in, gave us the slope. All right, so we're just going to go a little farther. First off, two things you need to write an equation line. You need a slope, which we can find easily, and we need a point. Agreed? All right, so let's go ahead and find the slope real quick. We just did that. So I'm going to have f prime of x. What's the derivative of x squared? Not just x, but 2x. Yep. Technically, it would be 2x to the first, but we don't write first. Okay? So it would be 2x. And then if I want to find f prime of -2, because that's the x value I'm worried about, just plug a -2 in. So I have -2 times -2. So my slope is -4. Okay, that's my slope. And then let's find a point. So to find a point, well, I can just plug x into f of x, the original. So let's find f at -2. That's going to give me my y value for there. So I'm going to have -2 squared. -2 squared is going to be 4. That gives me the point x is -2, y is 4. You all right with that? So the two things I need to find an equation of a line is a slope, and I need a point. So I got those two. Now I use point-slope formula. Y minus y1 equals my slope, x minus x1. You better remember that one from algebra, and trig, and algebra 2, and intermediate algebra, and pre-algebra. All right, plug it in. So y minus my y term of 4 equals my slope, x minus my x term. My x term is a -2, so we're making a +2. Y minus 4 equals -4x minus 8. Add the 4 across. Y equals -4x minus 4. So there is the equation of the tangent line for the function x squared when x is -2. All right. How's that feel? Okay. All right. Let's go on to the next one. Constant multiple. Hoping to get 2 more in. All right, so the constant multiple. Next one. If x is a differentiable function and c is a real number, then cf is also differentiable and d dx of cfx equals c prime of x. A whole lot of stuff going on there, right? Basically, it means if you have a coefficient, set the coefficient aside, and you can find the function and find the differentiate it, and then multiply them. Okay, so let's look at we'll just look at a series of these. So function and derivative. So let's start with this guy. Y equals 2 over x. Now, I'm going to write this one out the long way. It's going to seem unnecessary, but at least I want to do the first one like this. Okay? So, it's going to be derivative of y with respect to x. It's going to be d dx of 2x to the negative 1. So I brought it up top. So then we can apply the power rule. Okay? So technically, the power rule just allows us to take a negative 1 and write it out front, right? But by this constant multiple rule, because we have that constant, technically, we can take the 2 out front, just kind of sit it aside, and just find the derivative of this. Okay, a lot of people think the power rule is really the power rule and the constant multiple rule combined, which is fine. You can use it like that, but it's technically two different ones. All right, so now I would find the derivative of x to the negative 1. So that would be the 2. Then the derivative of x to the negative 1 would be negative 1x to the 0. Sorry, negative 2. My fault. All right. Which gives us then negative 2 x to the negative 2. And then I have to take that exponent, the negative exponent to the bottom, so I get negative 2 over x squared. Okay. So really, it's basically still just the power rule, but you just multiply when you bring that power out front. So power out front, 1 less to the power, you can just multiply it by the coefficient, whatever that coefficient might be. All right, just do a really, really simple one here. If I have f prime, or which go f of x equals 3x squared, f prime of x then, technically I would write the 3 to the side and find the derivative of x squared, or I can just really quickly know that f prime of x is going to be 6x. So I took 2 times 3, subtracted 1 from the power. Does that make sense? Okay. Now a couple more kind of ugly here. So we'll go f of t is 4t squared over 5. All right, so I'm going to rewrite this first as 4/5 times t squared. Okay, so then f prime of t would be 4/5 times the derivative of t squared, which would be 2t, and then 2 times 4/5 would be, what, 8/5? 8/5 t. Y'all still with me? Okay. All right. Do a few more using this guide just so you've seen a variety. So if I want 2 root x, this would be the same as 2 x to the 1/2. Right? So then I do that. 2y dx is going to be then 2 times 1/2 x to the negative half. So 2 times 1/2 is just 1. So I'm left with x to the negative 1/2, which is going to be 1 over the square root of x. Take the bottom to be 1 over x to the 1/2. 1/2 is just a square root then. Still good? All right. A little uglier here. 1 over 2 the third root of x squared. So before I apply the derivative, I'm going to rewrite this as 1/2, and then that would be x would be to the 2/3 power on the bottom, so it would be to the negative 2/3 power. So all I did was rewrite. Now, derivative of y with respect to x is going to be now 1/2 times negative 2/3 x, and that would be to the negative 5/3 because I subtracted a 1. All right, that's going to leave me then with a negative, what's that, negative 2/3, or negative 2/6, x to negative 5/3. 2/6 is the same as 1/3, right? So it'll be 1/3, it's a negative. And now that x to the 5/3, I'm going to take it to the bottom. That'll be right there. All right, let's look at one more here. Let's go y is negative 3x over 2. So dy dx is going to be, I'm going to write the negative 3/2 out front. Then I just have x. Essentially bring the 1 down. 1 less for the x. X would be the 0. So I'm just going to have times 1. So that'd be negative 3/2. Alright, so really just the coefficient tags along, apply the power rule, multiply the power rule and the coefficient. That's really what that whole thing's about. Alright, questions? Alright, just some more here. It says using parentheses when differentiating. So what I'm going to do, I'm going to put 3 up here. I'm going to give you a couple minutes to try them. So let's go f of x equals 5 over 2x to the third. F of x equals 7 over 3, and then x to the negative 2, and then f of x equals 7 over 3x to the negative 2. Alright, there's 3 problems there. Give you a couple minutes to try them. All right, so now you want to where you're at right now. Okay, that's a good spot. All right, now we'll apply that power rule. So then you apply the power rule, then you have the 3 out front. Okay, so say f prime of x is equal then to 5/2 times -3 x to the -4th, and then multiply it. Okay, so then multiply from there. So that's going to be -15 over 2, and then that x is to the -4th, so I want to take it to the bottom, right? So x to the 4th. All right. Second one, let's rewrite it. So I'll rewrite this as 7/3 x squared. That becomes positive because it's negative on the bottom. All right, so then I apply the power rule. So f prime of x is going to be 7/3 times 2x, which is going to give me 14x over 3. Now, the reason I had you on the last one, just take a note, second one and the third one are very, very similar, right? Difference being, second one, x has the power. Third one, 3x has the power. So I need to rewrite this and bring the stuff to the top to make it positive. So I have 3x squared. Well, now, are just power rules, not differentiation rules, but just our power rules for exponents. I have to distribute that 2 to everything on the inside, right? So I'm going to have 3 squared, which is 9, and 9 times 7. What's 9 times 7? 63. So I'm going to end up with 63x squared. All right, now f prime of x, now differentiate it now. I'm going to have 63 times 2x. So I differentiated the x squared, and that leaves me with 126x. All right with that? All right, now probably the easiest theorem, sum and difference rules. Basically, all this says is if you have a series, like a polynomial or something like that, and you want to differentiate it, and it's just plus, it's like 2x plus 4x plus whatever, you do each one of them individually, and then just rewrite it with the plus and minus signs in between. That's what all this is saying. So let's look at an example. F of x equals x to the third minus 4x plus 5. Okay? So there's 3 terms there, right? So this is kind of how I like to do it. Okay, these are going to be really common ones like this. I like to put little arrows. So what is the derivative of x to the third? 3x squared. Good. Okay. Negative 4x. Still the power rule, right? You bring a 1 down in front, multiply it, and there'd be 0 up top. So really, if you just have a whole number with an x, just eliminate the x. The derivative of negative 4x is negative 4. And then the last one, we had that constant rule, right? Any constant, the derivative of any constant is equal to what? 0. Exactly. So then what am I left with? Well, f prime of x equals 3x squared minus 4. Boom, done. I think that would be very similar to that one we did on that quiz. Okay? Remember I was able just to look at it and tell you what the answer was right away? That's exactly it. Okay, let's do one more, and then we're done for the day. We'll stop there. So g of x equals negative x to the 4th over 2 plus 3x to the 3rd minus 2x. And we were doing these, with the parentheses and the in the constant multiplier rule and those types of things. I hope that you can see, like, I'm going to do this one real quick. 3x to the 3rd. Okay? What's your exponent? 3. Bring 3 down front. Multiply it times the constant. What's 3 times 3? 9. X to the 1 less for power. Boom. Over here, negative 2x. If it just has an x, x goes away. So your derivative is negative 2. Perfect. All right. Now, this guy here, I'm going to bring him down. It's a little bit different. This one here, I'm going to rewrite. I'm going to go negative 1/2, just so I can get just the x to the 4th by itself, which would be 4x to the 3rd. Okay, multiply that, and I'm going to have negative 4 times negative 1/2 is going to be negative 2x to the 3rd. Okay, that's the derivative of that. So then g prime of x, negative 2x to the 3rd, plus 9x squared, minus 2. Boom. Done. Questions?